talk. So this is general form of the polynomial. So obviously, if you draw the map, if you use a graph, because this is very useful if you want to study calculus, that is where we can start with. So basically the dependence, if the variable depends on others, that variable is called a function, right? So that is so if you draw the graph here, then you will see depending on the degree of this of the polynomial, not polynomial, it's polynomial. Yes, if you put the vertical is n. So this is function, which is it's called what's called a polynomial. Polynomial. This polynomial is function. So in a special case, can be straight lines. For example, if you just put a linear, yes, if you linear term, that's just this is linear. So if you got linear, you will see this straight line. But if you go to quadratic, then you get started for quadratic, give something like this. So you give something like this. So got a parabola, can you see? So and so on. If you go to cubic, this is just quadratic. If you go to cubic, and that can be something like this, can you see? So certainly anything beyond the linear is nonlinear, all right? But this doesn't stop us to use matrix to represent the polynomial. So we can in the first step, we're talking about transformation afterward. In the first step, we can represent this polynomial as vectors. This is a bit abstract. So this can see, because in all these terms, the determinant factor or the most is characteristic. So it is their coefficient. This is called the coefficient, right? The numbers in front of this x coefficients, yeah. So coefficient is actually the governing the different particular form of polynomial. So what can we do? Use our formula. How can we represent this by a vector? Can we just represent a polynomial by a vector? What can we do? Think about it. So after all, we are just concerning the proportion of different terms. This is x0 term, right?
Right.
Okay, this is x1 term, yeah, and so after all, we are dealing with this proportion, okay, and this proportion, we know the form is given, all right. For example, you can check. For example, every form is given. For example, if you want to know the C101, all right, that would be the coefficient for this term, 101. Can you see?
Yes.
So if you just want to simplify something, then there's no point to keep this to take this part into account, because that is apparent, because the subscript here will give you the information. Okay.
Yes.
So in this way, what can we do? We can just write the vectors, column vector. Can you see?
Yep.
For the C0, C1, C2, and so on until Cn. So in this way, a polynomial in algebra can become the vectors, and that can be manipulated by matrices later on. Yes.
And the matrices would the matrix would hold the
well, depend are you looking for, all right? For example, we are looking for in general, because if we have the polynomial, okay, what we can say is that after a transformation, which is in the matrix form, 0 became something else. So I should write other way around. So that's why if we just we multiplied m, which is a transformation. Okay, this could be any transformation. okay, but must be linear.
Yeah.
If you use a matrix, must be linear,
see.
okay, but this is good example that the transformation linearity of the transformation has nothing to do with whether the function is linear or not. Now, if you multiply the p, can you see? In principle, what we can say, we can get something else. Do you agree? Can we call it q? Of course, the actual form of q will depend on the matrix, okay? But because we haven't started the calculus yet, I just go to further. I just give you, doesn't matter. Can we just say, if you know the calculus, the first derivative of this one, of the polynomial is simple. This is notation for the first derivative. So that will give you something else. That will give you they give you C1 from start C1, and then
like
2C2 x here, and until n multiply Cn, and then xn minus 1.
Yes.
Well, anyhow, so this one from here we can form another matrix. Can you see? From here we can form another matrix. Now this matrix may different, so that's why you can form the Q. Can you see that?
Okay. Yes.
Okay. The Q and P are different. However, this difference can be well represented by this matrix. So this, you can call this a transformation matrix. Okay, I stop here after we will revisit these issues after we start calculus, right?
Sure.
But
so
I
give me
think
2 seconds. I'm just going to fix up my screen.
Okay.
Lucky I've got a backup screen, so when one screen goes down, I can use the other one.
Okay.
Okay. 2 seconds.
No problem.
I love technology.
We became dependent. So we became linear dependent.
we have.
We have non-linear
We
dependent.
are linear. Definitely. Oh, now my webcam's not working. Let me just turn that one on. Start video. Excellent. Okay, we're back.
Okay.
Great.
All right. So we'll go further. So we just remember that the polynomial it can be represented by a vector, and some of the, not all, some of the transformation can be represented by a matrix. Okay.
Yes.
But today I'm talking about something perhaps is relevant to our extension, or should I say, is extension of our discussing. You know, the another matrix. What see Nisny? Oh yes, right. Have you heard of Nisny matrix?
No.
Oh, oh, that's good. That's something very interesting. By the way, Nisny is French. Is French? I'm not sure. But his first name, Nisny. What? Can you guess what his first name?
Pierre. No.
No, sure.
Pierre?
Patrick.
Oh, Patrick Leslie.
Yeah.
Ah, that's not very French.
Well, I don't know. Google that. Yeah, Google that.
It could be. It doesn't sound as French as, say, I don't know, Poincaré or something. That's.
Yeah. Well, it's not important, but basically, of course, his full name is Patrick. Yeah, it's Patrick.
Patrick.
Yeah,
Patrick.
Patrick. Oh, Patrick. French. Okay. Anyway, that makes things more closer to you. Yes, this is very good, very good example. Okay, the idea is actually this guy is not a mathematician. He's a biologist. I think he studied biology. Okay, he came out with this idea. And this idea has been widely used even today to predict the population. Okay, so this is to populate, how to use this Nisny to predict the population of any species, but in human in particular, population. You know the Australia Statistics Bureau always publishes this data every year, and to give the not just total number, but also the breakdown of each gender and also even each age group. Okay, because I have several students doing the the math 12, year 11 assignment. So I think that would be a good idea to let you know that this is a very good example to deal with a practical problem. Of course, the idea is that this after he studied his biological system for some time, he came up that idea perhaps that the growth rate and the survival or death rate, or what we call the survival rate, can be used to predict the future population. So that is the idea. Of course, in general, you have to, if you ask for ordinary mathematics, and he would be started with differential equation, right? That is use calculus to solve the problem. But somehow, and this discovery, the problem can be solved by linear algebra. So basically, they just define what is population. Okay, population increase or decrease. Okay, depending on how you look at it. Okay, you can choose a particular country or state or even the city, and if but unfortunately, these systems are often open. Okay, so that creates some difficulty because people come and move out, they immigrate and migrate. This is people. That's one thing, and another thing is the population itself is dynamic. Okay, so if you just divide the total population, it's called the total population, can be at least divided according to gender. So you got a male and a female. Okay, you get a female.
Yeah.
In addition, that we can also see their age group. Okay, their age group. This is called this age group. That's important category. If you look at down the age group, something very interesting would happen. For example, there's difference between the male and the female now, because the male just getting old or die, or by sometimes by accident die, and but for the female it's different. Can you see? So for example, if you have a different age group, so this is younger age, just go to 3 group. Just go to 3 group. Okay. You can go to further. You can have 5 or even got any age group. Can you call this is 0 to 20, right? 21 to say 40 something. Plus 20, 39 or 40. Can you call 40, right?
Yeah.
And that is 41 to say oh, that we stop there. Probably 60 something retired. Okay.
Sure.
Yeah, 60. Now, for the different gender, and you will notice that there are some variables are different, okay? Because between the middle group, they give birth, they give baby, right? So therefore, these were certainly, of course, according to probability that whether you have boy or girl is half, okay, 0.5. So the probability, so that is something that makes the female category different, unique, okay? That's different from the male group, therefore, okay? So they just start, say, this 41 to 60. So therefore, if after, so basically in this particular group, you have to consider their contribution. So in this particular group, second group, you have consider that they will give the baby. So therefore, you have, when you study this dynamic population, certainly you have to see they will make both boy and girl to that first group. Okay. Yes. On the other hand, if nothing happen, this is just naturally occur if you just count. Okay, after 1 year, or after, in this case, after 20 years. And this group people will all become group 2. Can you see? So you have to take this into account. Of course, in the meantime, you have another consideration that some people, have accident or whatever reason, they just disappear. Okay. So I draw this map, I draw this one, just to remind you, this population is changing all the time in each group.
Yes.
It's more complicated than when you consider the total population. The total population is much simpler, right? So if we can try to to see the total population, I believe it would be very close to a constant. Do you agree? Very close to a constant, if nothing, or the gradual or gradual increase, if you take into account the immigration into account. So that is basically, if you're just looking for the total population, I just break it down into this. If you look it down, the total population of any state. So this is total population. So this time, so you would say probably the population just increase like that, right? Very close, and some down, and probably some like so very something like this, all right?
Yeah.
However, if you break this population down into this age group, and things will be changed, will be slightly changed. Can you see? So depending on how to describe that, if you use color to describe them, so you will see that. So that's a T, and that is a P. It's a segment. It's segmented. So we're talking about the notation here. Perhaps we put can we put P here for the age group? Can we use age? Can we use age group P here? Right. This is total. T for total. T for total. Yes, total. So if you follow the age group, we don't know. This is just hypothetical. Can we just say, can we use this age group is green? The first age group is green. So how do we do that? So the age group pretty much is a constant, right? So pretty much is a constant like this. Okay, pretty much is a constant. And others, can we just use different colors? Can we use or you have used orange already? Can we use the blue for the second group? And it must be very close, right? If you after for a while, so basically we just exaggerate the difference. They are different. Basically, there's something like that.
Yeah.
Perhaps some abnormal change. The purple, can we use the purple for the third one? So third one would be like that one, probably some sort of third one. Okay. Just make something dramatic for some reason. Okay. So the task to do this, to apply the linear algebra to predict this the age group, population age group, is by considering all of these factors that influence the change in each group. In addition, this is just natural factors. Others, including the physical, the people travelers, okay, the temporary residents, and the people go overseas or people from overseas, they will change the population. So therefore, you see sometimes you will see this the bump here. Perhaps that's due to the relative large immigration. So that so what my argument my concern is that my argument is that the population is recorded in respective whether this number belong to. It's a sum. It's a total. It's simply the sum, right?
Yes.
So, yes. But we still can talk about what we call the equivalent rate. For example, in this origin color, it could be describe people who simply left a particular state. Okay. So of course, in this case, the births, apart from this adding into the age group 1, other things could happen that will make that, for example, the people come from other state, and they could increment. They will make that they bring their baby, so that will increase that each group. Can you see? So things can be given complicated. It get complicated. Especially retired people go to Queensland. See, after retiring, they go to Queensland. So probably there's more people come to Queensland in age group, last age group. But anyway,
Yeah.
that is very complicated. Think about it. It's very so many variables. So what can we do?
Yes.
So what can we do? I think that the first thing is to have to follow this age group. Can we just, today we just discuss the female group, because female group have unique contribution to the growth. And naturally between the 20 or 40 or even, yeah, that is a statistically is a peak. The female give the birth to the babies. So therefore, perhaps we just focus on, today we just focus on this particular age group or female age group. Okay, so we're not talking about every issues where, and in the statistical bureau, they also give you the breakdown of the different, different category, and that allowed you to work out that individual group, age group, that their rate, the growth rate, and also what we call the survival rate. And survival rate and death rate are related anyway, because the survival rate and the rate, the sum must be 1. Okay, perhaps we will go to some statistics at some stage, right?
I'd love that.
Yeah.
that's my main. I think my main mathematical interest.
It's good. You see,
probability and statistics.
Yeah. Do you agree? They when talk about the rate, they have three rate of importance or relevance in this case.
Yes.
Write down. So we have to incorporate this rate into our modeling. So So the 3. I think it's 2 would be enough, but I put the right 3 rate here. One is growth rate. Okay, population growth. So how to define this growth rate? Can we just use a G? We use a G, right?
Yes.
So the growth rate would be just change in the change in the growth. Can you see? It's just the change, right?
Yeah.
Do you have divided the population at a particular time?
Do we want it as a percentage?
Percentage, yeah.
Just as a
percentages.
Yeah. So you'd have the delta, or you'd have the new population divided by the old population minus 1.
Minus 1. Oh, can you write down for hang on, I must join the member.
Or delta G over the change in population over the original population.
Yeah.
Divided by
multiply.
Change in population.
That hang on, how to define the growth? Hang on, this probably my writing is not very good. The growth would be the growth rate. Can you see? We're talking about growth rate, right?
Yes, it would be. Wait up, I think I can write it out. It would either be.
That's your expertise, the economy. That is growth rate. Yeah.
That is one thing. Where's my pen? Oops, there we go. Equals. Really new divided by old. Take 1 would get it in percentage.
Okay. Yeah. Okay.
Or new take old over old.
Okay.
So that would be the delta.
Yes. So basically, it's a rate. Okay. Can we call this rate is can we call R? Probably just I'm searching for the notation. Can we call the growth? This rate of growth, right? Can we use this notation? G for growth, right?
Yep. Sure.
So that allowed us to work out. We should be able to look out. It's just a compound interest, right? So you got is that right?
No, that's right. Sorry, I was not thinking about compounding.
Yeah,
I see.
Yeah, because that's you minus 1 here. So basically, this is previous year's computation, right? Can we call it first year plus the G0? Okay, that will give a population of second year, right?
Yes.
Yes. Right. So that's 1 will equal to G0, 1 plus RG, Is that right?
Yes. Yes.
So
Yep.
so basically this rate, these factors can be worked out by these two. So in other words, this give you the mathematical, what we call the geometrical matrix. So therefore, I will return to your formula. So that will equal to G1 divided by G0. Okay. So therefore, the RG, the growth rate, will equal to G. Yeah, it's same as your formula. Can you see?
Mm-hmm.
-1. Is that right? Or different?
Yeah.
Depend how you define the rate. Define how to define the rate.
Yeah, I think it's the same. I think RG is, yeah, no, I think that's the same.
New and old,
G1.
see? Yeah, you call the new and old, see?
Yeah, so I meant that
new
to
and
be
old, new
G1,
and old.
G0. Yeah.
Okay, so that is formula.
Yeah.
So basically, then if you yes, in 10 minutes we have to change. I've changed again. I got a message.
No,
Now.
okay.
It's okay.
All good.
This is yeah. So we're trying to figure out how to define the rate. Okay, there's the first rate,
Yes.
growth rate, and so that is formula. The second rate would be the surviving rate, the survival rate, surviving rate, or survival rate. Survival rate, surviving or survival, survival rate.
Yeah.
Survival rate. How to define that rate? Can you call the rate for the S for survival?
Mm-hmm. I am not sure.
So people decrease, right? Certainly, the survival rate. If the survival rate is 100%, there's no change. You see, for example, if nothing happened and this group were after 20 years, they will become a second group.
Mm-hmm.
But however, there are some accident. Okay, so you have take away of the what we call the death rate.
Mm-hmm.
Because that will affect the outcome of next how many people can successfully move to the second category, right?
Yes.
Is that right?
Yes.
So after all, this is something to do with the probability, you see. In other words, people can survive and people can die will be 100%. There's no other choice.
Yes.
You either survive or die. Do you understand?
Yeah.
So if you are very sick, even people are very sick, you still survive. Can you see?
Yeah.
The people. So when the bureau, the Australian bureau, only take just a count, people alive or die. That is how they do. So that is another. But how about the formula? How can we find this formula for the survival rate? Let's go to next page. How to find the survival rate? So we got the growth rate were equal to the new one, the new and over old -1. Mm-hmm. How about the survival rate? Will be the same? Presumably the people, in this case, we have assumed that there will be less people, okay? Because some people, certain percent of people disappear, okay? Oh, by the way, this death rate also can include people who actually left a particular area or territory, okay? Because they are not a part of the population anymore.
Sure. It's an abstract death.
Yes, okay. So how to write this one? Can we use the same formula or not?
Yes.
Can we? So depend how to look at these numbers. For example, if you have this is 1978, this is 1979, and the population says is 1,001, and then you got 900. Well, that's not have changed. It's just hypothetical, okay?
Sure.
So if this particular age group change that much, so how do we calculate the survival rate?
The survival rate would be.
Can we use this formula? Can we use this formula? Perhaps we just using it to work out the death rate. Is best easier to calculate.
Yes.
Okay.
Sure.
So if there's the only reason the population change, then we must confirm that we can so that how many people die. So that would be 1 0 minus take away, right?
908. Yep.
Okay.
Sure.
So in this way, yeah, this difference.
107. No. Sorry, 90. What is that? 93.
93, right?
Yeah.
93. So we use this difference. Can we use this is difference, the change, so that the death rate can be worked out by use this difference, right? That's a change, the change in the numbers, change in the population, change in the population, change in population, and divide by the number. The same formula, right?
Yeah, the same. Yeah.
So must be that's be the negative, right? Should be negative or positive?
It should be negative. Negative delta P over G0 will be negative.
You work it out. I'm a little confused.
I think that'll be that over that.
Yeah.
And that will equal 93 over 1 0. So that'll be negative 93 over 1.
Yeah.
Which will equal, I think it'll be like round about that, negative 9%.
I think it should be positive rate. Do you agree? Otherwise, survival rate, if you put a negative number there, the survival rate will be over 100%.
Yeah, okay.
We probably have to